Welcome to the deep dive. Today, our subject is the worldview of Akash Dhawan. He's this really interesting thinker focused on mathematics and astronomy.
Right, but the unusual thing is we're not looking at his academic papers directly.
Exactly. We're trying to decode his whole philosophy, basically, from just four philosophical riddles he put out there.
Which is quite a challenge.
It is. So our mission here is to pull out the core principles he uses. How he structures his understanding of the universe and human experience.
And it seems to boil down to this blend of abstract thinking and, well, hard numerical proof.
Okay, let's dive in. The first big theme seems to be this drive for numerical order. The first riddle talks about how numbers whirl as the sun and stars. And Dhawan sees his own work as like spinning the heavens into order, turning chaos into cycles.
It really suggests a belief that underneath all the apparent randomness, the universe fundamentally runs on predictable cycles.
So what's the implication there? So what?
Well, it's incredibly ambitious, isn't it? He's basically defining the ultimate purpose of mathematics in astronomy.
Which is?
Cosmic predictability. Using math to lay down these cycles so that, and this is his phrase, the universe always knows its place.
Wow, okay. Like imposing a kind of certainty onto everything.
Precisely. An assertion of control over uncertainty. And he kicks it off with this idea: to seek is to begin the equation. The very act of looking for order starts the mathematical process.
Right. Seeking is the start. So that desire for structure, for cycles, it then leads into the second riddle. And this one surprisingly shifts focus.
Yeah, it moves to the human realm, to struggle, actually.
He describes human effort, get this, like a CV battle between glory and loss.
It's a striking image.
It is, where yesterday's rallies are erased by today's anxieties. So what's the mathematical concept bridging the cosmic order and this, very human up and down experience?
Okay, so the key concept here isn't just resilience in a general sense. It's more specific. Convergence, mathematically speaking.
How so?
It's like the constant mathematical attempt to find a stable limit or a predictable curve. Even when the individual data points, the wins and losses, the rallies and anxiety seem all over the place. Erratic.
Ah, okay, so the failures aren't just noise.
Exactly.
Yeah.
Dhawan seems to suggest they actually contribute to the long-term proof. They're part of the data set that eventually converges.
But how does he actually prove that stability emerges from the chaos? I mean, it sounds quite philosophical still.
Well, that's where he brings in this idea of rigorous validation. He uses mathematical induction as a sort of model.
Induction.
Yeah.
Remind us quickly.
Sure. It's the idea where if you can prove a base case is true, and then prove that if any one step is true, the next step must also be true.
Then the whole chain holds. Got it.
Right. So Dhawan says the induction begins where proof meets vision. He's arguing that every setback, every anxiety, isn't just a feeling. It's a necessary, verifiable step in this inductive chain, leading towards an eventual predictable truth.
That really reframes things. Anxiety becomes like necessary data. Okay, let's bring in the last two ideas: connections and prediction. Riddle 3 uses this lovely metaphor.
The graph 1.
Yeah. Life is a graph of connections with tangled streets, but the goal is always unexpected unity.
I like that. Unexpected unity. And this is where his philosophy really starts to crystallize, I think.
How so?
If you connect this graph idea to the bigger picture, he seems to be arguing that all of reality, whether it's social networks or, gas clouds between stars, fundamentally has the same structure. A structure that's mathematical.
Governed by math.
Yes. Which leads him to this incredibly bold statement: quod mathematica veritas est.
What is mathematical truth is truth?
Basically, yes. If it's true in math, it's true, period.
Okay, that's profound, but hang on. If mathematical truth is the ultimate truth, does that leave any room for, say, human discovery or agency? Is it all just predetermined by numbers?
That's a really good question. And maybe for Dhawan, the discovery isn't in finding some pre-existing formula out there, but in the act of proving it works, in demonstrating it.
Ah, the verification.
Yes. And he puts this straight into practice in the fourth riddle. He takes this unity principle and applies it directly to observation. He talks about reading the sky's resume.
Like piecing together the data points.
The connections on the graph, exactly, to predict patterns. His example is forecasting tomorrow's monsoon.
So it's not enough to just believe the mathematical truth exists. You have to confirm it. Through observation, through calculation.
Absolutely. For him, astronomy isn't just stargazing. It's this discipline of rigorous validation. And his final mandate ties it all together beautifully.
Which is?
What is written in the stars must be proven in numbers. You need both. the observation and the proof.
Okay, so stepping back, if we boil down de Haan's whole approach, for you, the listener, there seem to be two core demands. First, you need to find the order.
Find the patterns, the cycles, and all the chaos, whether that's cosmic stuff or personal stuff.
And second, you need proof. That apparent order isn't enough. It has to be backed up step by step with rigorous, ideally numerical validation.
It's a really compelling framework, actually. This synthesis of looking closely and calculating carefully could apply to almost any complex system, couldn't it?
It really could. Okay, so here's the final thought we want to leave you with today. If de Waan is right, if every problem, every detour is really just a path towards some kind of unexpected unity, what tangled street in your own work, or maybe your life could be a business challenge, a research problem, debugging code, anything, what tangled street are you on right now that this disciplined approach, this idea of mathematical convergence, might help you navigate, might help illuminate?